So we're going to look at, I'm actually going to do questions 2 and 3 with you. I'm going to skip question 1 because question 1, they gave you the data that you need. Remember, for percent yield, you're just taking your actual yield, dividing it by your theoretical yield, and multiplying it by 100. So when you look at question 1, they've already given you all the numbers for that. So there's really simple math you got to do for that. You're just really plugging the numbers into the formula. So, but reading these can be a little tricky. So I am going to read number 1 with you, just to help you identify which one is the actual yield and which one is the theoretical yield. So when you look at this, it says a reaction with a calculated yield of 9.23 grams. So when you see that word calculated, that's your theoretical yield. So a reaction with a calculated or theoretical yield of 9.23 grams produced, that means you actually made it. 7.89 grams of product. So the 9.23 is your theoretical yield, and the 7.89 is your actual yield. And then they're asking you, what is the percent yield for the reaction? So all you're doing is you're taking your actual yield, the 7.89, and dividing it by your theoretical yield, which is the 9.23, multiplying it by 100, and you'll get your percent yield for that one. So I'm not going to do that one out. I just walked you through how to do it so you could tackle that one. I do want to do numbers 2 and 3 with you. Questions 4 and 5 are just like question 3. So do use what we do for number 3 to help you with 4 and 5. So let's take a look at number 2. Right. So number 2 says 5.96 grams of ammonia. This number in parentheses is the molar mass of ammonia. So you don't even have to calculate that. This worksheet's pretty nice. It gives you that. And you should have a heads up. If they're giving it to you, you're probably going to need it. So 5.96 grams of ammonia react completely according to the following reactions. So that is a key phrase, react completely. This is a huge clue. This clue tells you that the ammonia, which is the NH3, that the ammonia is your limiting reactant. That's a huge clue. That is a huge step saved here. We don't even have to calculate which one of these reactants, the ammonia or the carbon dioxide, we don't have to calculate which one is a limiting reactant. They're telling us which one's a limiting reactant by saying react completely. So ammonia, I'm going to put a box around it. The ammonia is our limiting reactant based on how this sentence is worded. By the way, these little letters in parentheses, I've never really drawn them before. This worksheet has them. That just tells you what state of matter this compound is in. So G is gas, S is solid, L is liquid. If you see an AQ, which I don't see any on here, if you see AQ there instead, it means aqueous. It means that that thing, whatever it is, that solid most likely, is dissolved in water. So if you see AQ there, again, there's none on the sheet that I see. It just means aqueous. It means the solid is dissolved in water. So we know from the wording of this sentence that is our limiting reactant. So watch out for that. If you see react completely, that is a huge clue that that compound is your limiting reactant. It saves you a huge step, right? So then the question is, what is the theoretical yield of urea? That's the compound. So they're giving us, that's the urea right there. That's solid. That's water. And that is the molar mass of urea. Should have a unit after it. It doesn't, but it should be grams. What is the theoretical yield of urea for this reaction? So we need to figure out how much of this product, this urea, are we going to make with what we're starting with our limiting reactant, which is our ammonia. So again, as always, I like to write out what am I starting with, where am I going. So I'm starting with 5.96 grams of ammonia. And I'm being asked how many grams of urea am I going to get? So we're going grams to grams. So that means we're going to need molar mass in here because we're converting from one compound to another, which means we're going to need molar ratios as well. Now, if we didn't have this react completely thing, right, we would have to figure out which one of these two compounds is our limiting reactant, which means there'd be another number in here because they're telling us 5.96 grams of ammonia. We would need to know how many grams of carbon dioxide as well. That's another clue. If they're not giving us how much carbon dioxide is going into this equation, then it's not the limiting reactant. But if they gave us, the ammonia amount and the carbon dioxide amount, we'd have to figure out which one of these two makes the least amount of the urea. But we get to save that step. So what we're doing is we're converting the 5.96 grams of our limiting reactant, ammonia, into how much of the product we're going to make in grams. So we start out by writing 5.96 grams of ammonia. Okay. We're going to convert grams to moles because molar ratios are in moles. So they already gave us the molar mass of ammonia. We don't have to calculate that. So thank you, sheet. Okay. And that's in 1 mole of NH3. The grams of ammonia will cancel. Now that we're in moles of ammonia, we can convert moles of ammonia to moles of urea. So you do that by using your molar ratios. There's a 2 in front of the NH3. Did you see how I saved that? N turned into an M. And then there's a 1 in front of the ammonia. Again, moles will cancel. You do this math out, you will get a theoretical of 1 moles of CN2OH4. Since this worksheet is mostly in grams of things, let's take it one step further and convert this into grams, which you could actually do in the same thing. If you wanted to carry this out one more, you could do 1 mole of the CN2OH4 over the molar mass, but you could do it this way too. So then you would take the 0.17 moles of CN2OH4, right? Your molar mass is the 60.056 grams of CN2OH4. And that'll put us into grams of the product, which is 10.5 grams of CN2OH4. So that is our theoretical mass of the urea that we should get, the theoretical yield. Again, I didn't stop here, and I really should just continued this and done this conversion factor and that, but I forgot. I didn't stop here because if you look at this sheet, if you scan ahead, most of it's in grams, so that's why I just did the conversion of moles of urea to grams of urea there. So that's number 2. This was calculating theoretical yield. We took our limiting reactant, which was already identified for us, and then we just converted that. We converted it to grams of our product, right? So let's do number 3 together. Again, number 3, 4, 5, the process is the same for 3, 4, 5. So I want to do number 3 with you. You should be able to learn 5. So if we look at this, always read your problem first. Starting with 9.87 grams of ammonia, that's the molar mass of ammonia, react completely. There's our clue again, that ammonia is our limiting reactant, plus the CO2, that we don't have any numbers for that. So then clearly the ammoниa's got to be our limiting reactant. 9.87 grams of ammonia react completely according to the following reaction. If we look, it's the same reaction as number 2. 4 and 5 have different reactions, so just be aware of that. If 13.74 grams of urea, that's the molar mass right there of urea, are produced, so that means that 13.74 grams is our actual yield, because if they're actually produced, what is the percent yield for this reaction? So what we need to do first is we have our actual yield, the top number of the percent yield formula. We need our theoretical yield, which is that bottom number of the percent yield formula. So we have to first calculate the theoretical yield. That is our first step. We've got to calculate that first, right? Because we need that number. We've got to calculate how much of this product here, this urea, are we actually going to make from 9.87 grams of ammonia. So as always, I like to start out with, what am I starting with? I'm starting with 98.7 grams of ammonia. And they're asking me how many grams of urea is that going to make, right? So again, I'm going from one compound to another, so I'm going to need molar ratios in that. I'm working with grams, so I'm going to need molar masses for that. So the theoretical yield We start out by writing 9.87 grams of NH3. This process, by the way, is the same as what we did for number 2, right? So we're going to draw our lines of our molar mass of ammonia. So they gave us in the problem. Okay, now I can convert from my ammonia to my urea. And again, we have this number is coming right from there. 2 moles of NH3 to 1 mole of ammonia. Okay, and this time I'm just going to do it right in here. I'm not going to do a separate step like I did in number 2. So 1 mole of the CN2OH4 has a molar mass of 60.056. OH4. And when you calculate this out, so again, grams will cancel, moles of that will cancel, you will get 17.4 grams of CN2OH4. That is our theoretical yield. According to math, this is how much urea we should make if we have 9.87 grams of ammonia going in. But if you look, we didn't get that. We got an actual of 13.74, so we're going to do the percent yield. So how do we do that? We do the actual, divide it by the theoretical, multiply that number by 100, and we get a 79% success rate. That is our percent yield. Right? So we've had to first figure out the theoretical yield, because we weren't given that number, and then we could divide it by our actual, and there you go. So if you're presented, and again, 4 and 5 are the same process as number. If you it's just different compounds, different amounts, but otherwise, exact same problem as number 3. So give those a try. But this sheet skips this figuring out the winning rate. Let's just say that for number 3, it said 9.87 grams of ammonia react with 10 grams of CO2. What's the percent yield for this reaction? Given the amount that you actually make. You're going to have to first figure out which one of these two produces the least amount of the CN of the urea here, and then you would use that answer to figure out which one's your limiting reactant. Use that answer as your theoretical yield of urea. So this sheet has you skip that step, but there may be a situation where you have to do this again. We did this number here. We got this number using ammonia. If we weren't told that the ammonia is a limiting reactant, we'd have to do it for the carbon dioxide as well. And then whichever one, the ammonia or the urea, carbon dioxide gave us the least amount of urea, that would be our limiting reactant. That would be our theoretical yield. And then that would be the number that we plug in here. So just realize that this sheet has you skip that extra math of figuring it out for the other reactant. But give number 4 and 5 a try. Again, as always, the answer key is available online so you can see the math. Don't recommend copying it. Doesn't help you in the long run. But yeah, go ahead. Try it.